Hello and welcome to this video on factorising quadratic trinomials, part of the Year 9 course. My name is Darren from Maths Guru. Thank you very much for watching. Now if you can, before I get going, can you please subscribe to my YouTube channel? Sounds a bit needy really, doesn't it? But by subscribing, it just lets me know that someone out there is actually watching this stuff and I'm not sitting here talking to, well, even the dog's left me now. He's like, oh, you're not making any sense. So by just subscribing, it actually means the world to me. Every time that little counter goes up by 1, I'm like, oh, yay, this is awesome. It's quite sad really, bearing in mind I'm 147. If you want to, you can head over to maffsguru.com down there and actually sign up. It's absolutely free. And what you can do is you can watch the videos, you can download the notes that I'm writing behind. Really good for your summary books if you're over here in Australia. There are going to be exam questions, all the VCE questions and all the VCE courses are on there as well. So hopefully this will prepare you for a life of maths. And before I finish, can you tell your mates and your teachers about it? That would mean the world too, because if your teachers know this resource is there, they may actually use it and it could actually be good. Rightio, I'm done with that. Learning objectives, yes, well, they are there. You can have a look over them if you need to by pausing the video. And if at any point you pause the video or you need to, pause it, replay it. That's the whole point of this video. And obviously download the notes from maffsguru.com if you can. Now, everything we are doing, as I've said in a previous video, has something to do with a graph, right? We are dealing with these type of graphs. You may not know it at the moment. Your teacher may actually have already explained it to you why you're doing it. I know I do to my kids. But we know that when I can get it into this form, when I can take a quadratic equation, and I'll explain what I mean by that in a moment, or a trinomial, then if I can turn it into this factorized form, the number here in front of the first bracket or inside the first bracket actually helps us find that crossing point there. The number here at the end of that bracket, or the last number, helps me find another crossing point here. Really, really important stuff. And having the tools to be able to do that is going to help us later on in Year 9 when we get back to quadratics and we start sketching these things. So this is the foundational stuff. This stuff is really, really important. Now, again, to recap what we've done before, and again, thank you very much, Cambridge, for letting me use your stuff. You guys are amazing. But in a previous video, we looked and said, well, if we had sort of algebra that looked like this, where the brackets in each term were the same, so like x minus 7, y plus 3, 5m minus 2, 5m minus 2. When we had something looking like that, then we could factorize it and turn it into sort of binomial product form. Yeah, so if we look at this last example here, if I factorize that out, I get the 5m minus 2, leaving me with m plus 4 inside a set of brackets. And there we go. That is binomial product form. That is factorized form. And I could actually take this and start to look at how my graph might cross the x-axis, right? And again, that's the whole point of doing this. But we have a problem. And we found that 3 things can't be factorized very nicely, which is pretty much where I started the last video. So I've got a problem. I've got 3 terms there, 3 terms there, and 3 terms there. Well, wouldn't it be nice if I could turn 3 into 4, which every time I do that reminds me of the Spice Girls 2 into 1, but then I'm showing my age and my musical taste, and I'm so sorry. But anyway, I digress. What we notice is that 3 terms is pretty hard. So if I had a way of turning 3 terms into 4, then I can go back to my previous video and I can start grouping by factorising and factorising again, and ka-ching, I get it into factorised form. So that's the whole premise of this video. Can we turn 3 things into 4 to group to then get it into factorized form? And as it turns out, we can. Now, when I was at school, I was taught something called the T method. All right, and basically it is a way of helping us split the middle term of a quadratic into 2 terms, and I'll explain why that happens in a moment. So here we go. Here's some examples, and it's probably best for me to show you examples. We've got x squared, he says, trying to write in eraser. X squared plus 7x plus 10. The whole point of quadratics is we have got to split these 3 things into 4. Now, we tend to notice that the x squared and the plus 10 stay the same. So we have x squared and the plus 10 stay the same. So I have to split this 7x into 2 terms. Well, all right, so I could have plus x plus 6x. That certainly works, doesn't it? I could split it up into x and 6x. The problem when I do that, though, is what will happen if I try and now factorize these two things together. Well, let's do it. I'd end up with x plus 1. What would happen if I now factorize these? Well, the most I could take out of there is 2 plus 2, x plus 5. Oh, well, I've got a problem now because I can't take that any further. Why? Because this bracket here and that bracket aren't the same, so I can't factorize again. Oh, that sucks. Right, well, that means then that x plus 6x isn't going to work. So can I have another one? Well, what else adds to give 7? All right, so plus 2x plus 5x. Let's see whether that works. Let's factorize the first two terms. So let's take out x, and we've got x plus 2. Maximum that comes out of there is 5. X plus 2. That's awesome. That one works. Seems a bit stupid to do this by trial and error, though, doesn't it? Because that's what I did. I was like, well, plus 7 could be 1 and 6 or 2 and 5. It could also be, I don't know, minus 2 and plus 9. There are lots and lots of different combinations. But in this situation, we could then go on and say, well, that becomes x plus 2. He says handwriting failing him. X plus 2. X plus 5. So we have factorized it. But is there a nice way of going from this plus 7 to the plus 2 plus 5? Well, yes, that's where the t method comes in. So I'm going to draw a t. And the rules of the t method is you take the number in front of the x squared and you multiply it by this last number. Now, the reason I'm saying this now is because, believe it or not, that's going to make the rest of quadratics really, really easy. Learn one rule. Some teachers break it down and go, oh, you do this, and then they change it, and you're going to do that, and then they change it again. And by that point, you're all confused. So what I'm now going to do is that number there is a 1. That number there is positive 10, and I'm going to write plus 10 on there. And I'm going to find the factors of 10. I'm going to find all the numbers that multiply to give 10. Well, I have 1 and 10, 2 and 5. That's it. Oh, 5 and 2, 10 and 1. Now, I am going to try and now find a pair of those that will give me 7, that when they add together will give me 7. Oh, okay then. So let's highlight those, 2 and 5, or 5 and 2. So actually, in this situation, I can use either of those because I now know that plus 2 plus 5 gives me positive 7. But 2 times 5 gives me 10. And again, part of the reasons we're doing this is what we notice is that when we add these two numbers together, it gives me 7. But when we multiply these two numbers together, it actually gives me 10. So that's where the t method comes from. Now, in that situation, what I would then have done is I would have used the plus 2 and plus 5, written it in here, and I would have had no trial and error. So let's try that one again. Okay, so what have we got? We've got x squared plus 2x minus 8. So we got to split this plus 2x up, haven't we? So the first term is going to stay as x squared. The last term is going to stay as negative 8. So we're trying to find two numbers that multiply to give negative 8, but add to give positive 2. Well, that's why I think the t method is so nice, because I'm going to write negative 8 up there. I'm going to find all the factors of 8 first. Don't worry about the minus sign for a moment. I've got 1 and 8, 2 and 4, 4 and 2, 8 and 1. Right, now we're looking for some of these numbers that will add to give 2. Well, at the moment, none of them are going to add to give 2, because that's going to give me 6, and that's going to give me 6, and that's going to give me 9, and that's going to give me 9. But I actually needed to multiply these numbers together to give me negative 8. So the easy way to do that now is to make one of these numbers, or one column, negative. Now let's check. Are there any of these that add to give 2? Well, that would give 7. Minus 2 plus 4 gives 2. Minus 4 plus 2 gives me minus 2. And that would give me minus 7. So in which case, there is only one possible answer there. And that is minus 2 and 4. All right, so cool. So what I now do is make that minus 2x plus 4x. And I've done the hard work, because what do I do now? Well, I'm now going to factorize that pair first and then factorize that pair. So let's take an x out of there. That's going to become x minus 2. Highest common factor of that would be 4. X minus 2. How do I know I've done this right? Because the brackets are the same, and therefore I've got x minus 2 and x plus 4. go. All right, so again, this T method is really, really handy. And if I'm honest with you, most people make the mistakes here on the T, all right, because they forget they've got to multiply the values to give the top value, but add to give the minus. And some people do this in their heads. I know that some teachers teach this using the cross method, which doesn't make any sense to me whatsoever, but theoretically it's the same idea. What about this one? And I'm showing you one example of all the different types that you might get. X squared minus 7x plus 10. All right, so the first thing we're going to do a T. Remember, we want the number in front of the x squared, which is a 1, times that number there, which is 10. So it's going to be plus 10. So 1 and 10, 2 and 5, 5 and 2, 10 and 1. Now later on I'm going to turn around and say to you, actually, you don't need to do the other half, because they've already come up here, they just reverse. But let me see. I want two numbers that multiply to give 10. Well, 1 times 10 is 10, 2, 5. Oh, awesome. And I mean plus 10. Uh-oh. Can you see the problem? I now want numbers that will add to give negative 7. Well, 1 plus 10 is 11. 2 plus 5 is 7. 7 and 11. Oh, 7, 11. Anyway. Oh. And here is a trick. When that is positive and that is negative, then basically each of these are both going to be negative. Because let's just check. Is negative 1 times negative 10, 10? It is, because a minus times a minus is a positive. Minus 2 times minus 5 is 10. But what is minus 2 minus 5 if we were to add those together? Well, I get minus 7. So in which case, that is the one I want. And again, the reason we're doing this is so that minus 2 becomes minus 2x. The minus 5 becomes minus 5x plus 10. What have we done? We've split those into two terms so that I've turned 3 into 4. And why do we want to turn 3 into 4? So that we can factorize it by grouping. So again, there's a bit of a trick in this one. Do you see where the trick's coming? Well, the first one, we can take x out. It gives me x minus 2. What am I going to take out next? 5? Nope, I don't think so. You're actually going to take out minus 5, because that's going to give you x minus 2. And again, where people make mistakes is here. And if you want to, pause the video, stop it, go back and check and do it on your own and make the mistakes with the minus signs that hopefully I can pick up with or for you. We've got two terms. They both share x minus 2. So there we go. We've got x minus 2, x minus 5. And we have turned 3 into 4 to make two binomial products. Anyway, too much information. Last example, let's see what happens here. We've got x squared plus 9x plus 14. Why don't you guys have a go at this first? Pause the video. Right? The trick here is the t, and again, it's always the number in front of the x squared times the last number. So 1 times plus 14 is plus 14. So what do we have here? 1 and 14, 2 and 7, 3, 4, 5, nope, 7 and 2, and 14 and 1. Okay, so they all multiply to give 14, and I'm trying to find a pair that add to give 9. Well, again, I could have chosen either, but I'll use that one. So therefore we get x squared plus 2x plus 4, try again, plus 7x plus 14. Factorize by grouping. So what's the best thing I can take out of x squared plus 2x? It's going to be just an x, so there's an x plus 2. Take out plus 7 there. Going to give me x plus 2. Am I right? Do I feel like I'm doing the right thing? Yes, because the brackets are the same. So I've turned 4 things into 2 things, so now I can do my binomial products. There's my x plus 2. There's my x plus 7. And I am done. Oh, this is amazing. There are lots of ways of doing this question. There's 2 ways of doing this question. But at this point in the textbook, if you're following along with the Cambridge textbook, you can actually factorize to factorize and factorize in. Now we're going to factorize 3 times. And if we notice here, we've got 2x squared minus 2x minus 12. And I notice that each of these terms can be divided by 2. So the question, or the textbook, wants you to take a 2 out to give you x squared minus x minus 6. And the reason being is it then says, well, you can now take this over and do a side calculation. So what I would now be doing is drawing a very, very wonky straight line. And I'd be saying, well, now let's deal with the question and pretend the question is x squared minus x minus 6. Right, so what I want to do, I want to take the 1 in front and times it by the negative 6 to give me negative 6. I've got 1 and 6, 2 and 3, 3 and 2, 6 and 1. I need a minus, so one of the sides has got to be a minus, and I've got to add 2 of them to give me negative 1. Well, in which case, minus 3 plus 2 is going to give me the negative 1. So I have x squared minus 3x plus 2x minus 6. Again, all we're trying to do by doing that is split that middle term into 2 so that we can group and group again. All right, so let me see. What have we got here? So we've got x minus 3. Take out a highest common factor of 2. Gives me x minus 3. We've got x minus 3, x plus 2. Now, the reason we're doing this is so that I can replace this with this. And so, therefore, my answer becomes 2 lots of x minus 3, x plus 2. All right, there we go. That is the way that the textbook has, but I'm going to throw you a bit of a challenge. I want you to see what happens if you don't do that. Try doing a t where you take, as I told you a moment ago, the first number times the last number. So 2 times minus 12 gives you minus 24. Find all the factors of minus 24, and then rather than factorize the 2 out, leave it in. See what happens. Here's another example, this one taking out the factors again, and again, we can do this in a different way, but I think in this situation it makes life easier if we don't. So what are we going to do here? What goes into 3, 6, and 45? 3. So let's factorize out the 3 first. What do we get? 3x squared minus 2x. How many 3's go in 45? 15. There we go. So there's 15. Having done that, let's now separate this out to its own question. So I've got, oh, he says writing in highlighter. X squared minus 2x minus 15. Now, I know that some people actually work down the page and will continue as part of the question. I just think there's too many brackets, so I split it out into a separate question. So let me draw my t. I've got this number, which is 1 times negative 15, which is negative 15. I've got 1 and 15, 3 and 5, 5 and 3, 15 and 1. It's a minus sign in front of there, so one of these has to be negative. And so what do we get? I'm looking for one that will add together to give me minus 2. It's got to be minus 5 and 3. All right, here we go then. So we get x squared minus 5x plus 3x minus 15. A lot of people always turn around and say, does it matter which order you put the minus 5 and the 3? It shouldn't make any difference whatsoever. You'll still get the same answer. Right, so let's factorize. We got this pair and this pair. So let's take out x there first. Gives me x minus 5. Let's take out plus 3 there. Gives me x minus 5. And again, if I'm going too fast for you, slow it down. I mean, not literally slow me down, but stop, pause, you have a go, see what happens, check as we go along. So what have we got there? We've got x minus 5 and x plus 3. Now, the reason we're doing this is so that I can now take this and put it in place of that, which gives me 3 lots of x minus 5 and x plus 3. Now, I could do the t method with this one, but the multiplication would be gross. And so in many cases, it's probably best not to bother and leave it like that. Now, we can actually do things in a different way, and we can do things backwards because that's what we love to do in maths. And we got an example here that I've now got to find what those question marks could be. So we've got x squared plus something plus 5. Well, now we can use the t method for good, like wicked. And if you don't understand what that means, that's fine. 1 times positive 5 would have to give me 5 up here. What are my factors of 5? Well, there's 1 and 5 and 5 and 1. Now, obviously, normally we'd be looking and saying, well, which two of these pairs adds to give this middle number? Well, all right, we'll just do it slightly backwards. That means that what is 1 plus 5? It is 6. And what is 5 plus 1? It's 6. So in this situation, the only thing that could be is actually 6x. Whoa, this stuff's amazing. Yeah? So using the t method, we can actually fill in examples of what that middle one might be. as it turns out, that's the end of this video. Thank you very much for watching. Now go away and practice, because practice makes perfect. And doing 20 of these questions will move it from short-term into long-term memory. And then you're going to be a gun at this when you need it a little bit later in the Year 9 course. Again, please head over to Maths Guru and sign up if you have the time and wish to do so. Absolutely free. Subscribe on my YouTube channel. Greatly appreciated. There are more videos coming in this series, and hopefully I'll see you in them. But otherwise, you take care and stay safe. Bye-bye.